We're also here to celebrate Sustainable House Day. That should be a national, not a national, but a national holiday, right? But it falls on the Sunday, so sorry guys, you can't get off. For Sustainable House Day, it's all about promoting good ideas and also showing people what's possible, and this is what we want to do with tonight. So we saw an opportunity to be able to show some of the houses all together, so you guys kind of get the download of information all in one night, and also maybe if you guys were thinking about going out on Sunday, you might be able to see the one you want to check out the most, for that matter. So that is this Sunday on the 13th of September. Make sure you register online to be able to get the addresses to where you need to go. So a little bit about Pecha Kucha. Pecha Kucha is really a rapid fire sort of way of communicating ideas. So we're really putting all of our presenters up to a big challenge today, because they got 20 slides and they got 20 seconds for every slide, and these slides don't stop, right? So I know I'm trying to mount pressure on them, but they'll be okay. But the really big thing about this whole thing is you got to be supportive of what they're saying as well. So even though it's going to be quick and to the point, they're going to give us some really good juice, and we hope you leave today inspired or wanting to do more in the realm of sustainability, especially in the residential sector. So our last presenter is Jeremy Miller. He's part of Sustainability House, and his background's actually an urban planner, but he kind of sneaked it into the design realm nowadays. And his main focus is to work with builders and developers into improving their energy efficiency, understanding legislative and statutory requirements, things like that. And Sustainability House helps a lot of architects, developers around the way. So one of their first homes from the Suho Design Studio is coming out, and he'll give us a little bit more intel on what they're doing. Welcome, Jeremy.
Thanks, Kim. Yeah, thanks everyone. Good evening. Great to see you all here. Yeah, I know. I have a habit of doing that. My voice is a bit too loud, and I always clip microphones. So I'll just wait for the presentation to fire up, and then I will begin. So yeah, Suho Studio is the design arm of Sustainability House, and we were very lucky to have a client in our midst who got us to design, and then he did the owner build on this beautiful little house down in Emily Street in Birkenhead. What we were really focused on is predicting the thermal comfort of the house, monitoring it, testing it, and then making sure that the house was really going to be comfortable for the owners. And how did you start with that? Well, you've got to find the right block. It's all about orientation. So the owners of this house looked for a long time to find the right block so they could start laying their slab and building their block and building their house from there. That's one of the most important things. Orientation cannot be surpassed. It's the foundation stone of everything. So we did some design on the house, and we came up with this really nice little, very simple design. We did the energy rating on it because obviously that's what we specialise in, and it got 7.5 stars. If you rate it with the current version of the software, it gets 8.1 stars. So it's a pretty high performance house. We were aiming for no heating and cooling. Being involved in building science and wanting to understand the science of the building, we did a lot of modelling on the house. So we're really interested in how the winter sun penetrates deep into the building envelope to warm up the polished concrete slab, it's actually a copted slab. And we want to exclude that sun in the summertime. So we built it out of SIP panels, the structurally insulated panel that you've heard a little bit about tonight. So it's one thing to get that slab down. Getting the slab down is the great achievement, but you've got to get your sequencing right when you do that. Unfortunately, the slab sat there for a little time, and because the SIPs arrived a bit too early, and were distributed throughout the neighbours' properties. In fact, the SIPs sat within 3 different houses waiting to go down. But this is how they're delivered. The structural panels come on the back of a truck on pallets, one pallet after another, and it's all in kit form with easy instructions. Why SIPs? Well, the continuous insulation barrier is the most important thing. Energy efficiency is the key. So very easy to put up. We've seen a couple of photographs already of SIPs going up, but 4 people, 3 days to get the walls up. So your walls all up, only a few days. But the key thing is you don't have to have extensive joinery skills. It's nailed and glued together. One of the essential things when you're doing this work with the SIPs is you get this sole plate down. The sole plate is the edge that the bottom rebate of the SIP fits into. it's really, really important that you get that right, because if you get that wrong, your walls don't line up. Thankfully, these guys made sure they got it done correctly first time, because once it's bolted to the slab, there's not much you can do with it. SIPs are very easy to handle. Basically, manual handling. You just got to just carry them correctly, and they're just so there's no mechanical handling on site. They're manually handled into place. The kit all goes together very simply. And once you get the walls up, we use the PosiTruss roofing system. Again, a prefabricated roofing system. Comes delivered on a truck. You get this beautiful span using this type of roofing system, and lots of space for fitting in insulation in your ceiling as well. So the outside of the building is then wrapped in a breathable membrane, and then you start packing it full of insulation. So as we saw before, it's really important not to compress that insulation. But it's also really important that you get into like these little places here. This stuff here is a phase change material. So we had a little bit of an experimentation with that. A PCM, phase change material, is an intelligent thermal mass. It's a lightweight thermal mass. But we've got the floor, but we've also got this beautiful recycled red brick wall in the building. The recycled red bricks, I love this. I just go, oh, beautiful wall. You can almost go up and kiss it. I love a bit of thermal mass, but I like getting the balance of thermal mass and insulation just right. It's really important. As we move, we get the site from a building site through to completion. We use the bamboo deck, sustainable, fast-growing, and we just very, very tightly fitted some rainwater tanks in down the side. Incredibly tightly fitting rainwater tanks, but they got in there. So as the house came to a conclusion, we've got a paper rock bench top in the kitchen. It's a recycled rock paper aggregate. You can see that red brick wall with the kitchen going in. But again, this beautiful bench top in the kitchen that if you come down and check it out, recycled timber with anchor chain as a tripod. Monitoring. We've been monitoring this house since it was built. We get some pretty impressive temperatures in the house. It's designed to stay warm over winter without any heating, so it's got no heating. Outside temperature, 3.5 degrees. Inside temperature, 16 degrees. No heating and cooling. Pretty impressive. All those figures are on our website as well. We're really interested in comparing how the house performs against predicted energy. So we do a predictive energy assessment on it, and then we do a look at the actual. So the red line is the predictive and the blue line is the actual. So they track very close to each other, but we found that the house is actually performing better than we predicted it. One of the reasons we like to test our houses, so we do the blower door testing and we do a thermography analysis on it. This house got 3.58 air changes per hour at 50 pascals. It's a fairly impressive figure, mainly due to the SIP panels and how well sealed that building envelope is. Your average Australian home is around about 18 air changes per hour. It's like leaving a 1-inch crack open the whole way around the house all the time. In this photograph here, well, it's all about comfort. 6 degrees outside, 20 degrees inside. Imagine that without having a heater on. You come home at the end of a cold day, you open that door and you walk into this beautiful warm house. In fact, the owners have said it's like being hit by warm air when you walk into the house. This is the sun penetrating deep into the building envelope on the winter solstice, heating up that slab, getting onto those walls earlier in the morning, and in the afternoon, it's right back into the far corner over that way. We've got this lovely video on our website that we took using one of these GoPro things, which shows the winter solstice happening. Now, if you come down on Sunday, it doesn't look like it's going to be raining. So you'll be able to stand back and have a look at the house, walk around it. You're not going to get rained on. But we really look forward, if you want to make it down to Birkenhead, come and check out Semaphore. There's a few other houses down that way. But drop in and come and say g'day, and we'd be more than happy to talk a bit more about that house. Thank you very much.